This video, we're going to add some wood trusses to this framing model that we started already. So as we've discussed in slideshows and lectures, this is the this is an example of a wood truss. So they're manufactured in the factory, often delivered this to the site by truck and lifted onto that structure by crane. They tend to be made out of, at least for the purposes of what we'll be doing, made out of 2x material. So 2x4s, 2x6s, perhaps sometimes 2x8s if you have a really long span. One of the primary advantages of this, this type of framing is that you can have a clear span that's quite far. So you can put the walls underneath it wherever you would like. You don't need necessarily a bearing wall. So long as you've designed the truss to meet the span. But one disadvantage of them is, as you can see with these cross member pieces, you lose access to a story or an attic space that you could have on that upper level. If you wanted to put a roof with dormers and have rooms up on that upper level, that would not be possible with this type of structure. But there are some efficiencies to it in terms of amount of lumber used, and as I mentioned with the clear span, there's some advantages to that too. So this is the type of truss that we're going to be using that we'll bring into Revit. So there's a few terms that you might want to make yourself familiar with. This down here is a bottom chord. Okay, these are the top chords, and these are the web members through here. Okay. You'll see a note here for the heel, and also the notation for the bearing. This is where the wall's going to be. In our case, we're going to design the truss to have an overhang like this so that you could have an eave and you could vent the roof through this overlap condition. So this detail on the top is what our detail is going to look like. You can see that top chord is coming over the top of the double top plates, and the bottom chord is resting on top of those plates. And of course, we have a plate that is attaching the two members together. So back in the Revit model, those trusses are going to be running in the north-south direction, and they'll be placed on top of, directly above the studs below. What you want to do first is go to level 3. And right now I can't see anything below, so I'm going to type in VR for view range. And I'll change them, the bottom primary range and the view depth, both to unlimited. All right, so now I can see the framing members below. To bring in a truss, you're going to go to Insert, Load Autodesk Family. And I'm going to type in here truss. And there's a number of types that are already that are available to you. We're going to go down to where it says Simple Think or W Truss and load that into the file. Okay, now when I go to Structure and Truss, I should see that Simple Think or W Truss standard. I'm going to click on Edit Type, and I'm going to duplicate the type. I'm going to call this Wood Truss and say OK. Well, this page comes from a manufacturer of trusses. So just to give you a sense of how to go about sizing and selecting them, up on the top here, we have a number of different load conditions, total load, duration factor, live load, etc. If we go with the heaviest load condition, which is this column right here, and we're using this common truss here, it is establishing a set of pitches. So typically the pitches for roofs are the vertical ratio over 12. So 2 inches high by 12 inches would be, this is the slope right here. So this is very flat. So if you're going to put shingles on a roof, this would not be a good idea because water would be getting back under the shingles. Minimum 3 to 12, but preferably something more in the 4 to 12 range is recommended. For our design, we're going to plan on a 6 and 12. So that means for every 1 foot, half a foot of rise will establish the slope. So it's going to be slightly steeper than perhaps most homes would be. And we have a span that's 40 feet. So I can use a top chord of a 2x4 and a bottom chord of a 2x4. And I should be within a fine range for what's possible for the truss design. So back in the Revit file, I'm going to edit the type here. So I'm in the one that I created called wood truss, and where it says structural frame type, set framing type, this is where I'm going to tell it that we want to make these 2x4s. So I'm going to go through all of them. Remember, the top chord is the part that's sloped. These are the web members, diagonal webs, and let's see here, the vertical webs, and then down at the bottom here, dimension, oops, I don't want to change that. We're changing this to 2x4s. Okay, and apply and okay. All right, now in order for us to get the relationship of the truss to sit properly on the bearing wall, we're going to span it a little bit further than these grid lines. So I'm just temporarily going to make a copy of this one. I've clicked on it and I'm going to make it, let's try 4 inches above here and copy 4 inches. Well, it might be a little bit longer than we need, but we'll see how that looks. Okay. And then I'm going to go to truss. And I'll go ahead and place it. I will make a change here. So the truss height says 8 feet. And since we're going with this 6x12, I'm going to make this, or 6 and 12 as the pitch. I'll make this 10 feet high. So it's 20 feet is half of the truss span, 10 feet high. That will give me my 6 and 12 pitch. Okay, and then I'm gonna start with the center here because I have a grid line that I can work with, and I'll go from those 2 structural lines that I just made. Okay, now we're seeing it as a single line because our detail level is set to coarse. If I set it to fine, now I can see some thickness to it, and I can also see that the web members are appearing. All right, so I can get a better look of this. Make sure your section is somewhere in this between 4 and 5 here. Go to section 2. Okay, I can stretch this cropped window up a little higher, and there we have our truss. Okay, now we'll need to make a few adjustments to it. But before we do that, let's click on that truss. First of all, let me measure. It's supposed to sit on top of the plates. So we're going to move it down. It says 10 1/4 here. So I'll click on it. And scroll to the top. Start offset minus 10.25 inches. And same thing with the end level. Minus 10.25 inches. Okay, so now it's sitting properly on top of the plates. But you can see that there's a few things that we're going to need to adjust. We're going to have to pull that bottom board back in and extend this one out so we have an eave. I'm going to go ahead and delete that copy of the grid line that I made. I don't need it anymore. Remove them from both sides here. And I'm going to actually make a copy of the original one, 24 inches over. This is going to be a reference for the eave overhang, as we saw in that product page. So let's copy this one. 24. And again, we'll erase these later. They're just for reference. All right, now I'm going to click on my truss and I'm going to tab until I can pick the top cord. Right now it's pinned, so I'm going to unpin it. You should see these triangles appear, which allow me to stretch it, and I'll stretch it over to that column line I just made. And I'll do the same thing over on the other side. Tab. Let's see here. May need to pick the truss first. Tab. There. Unpin it and bring it down. Okay. Now the default relationship looks like this, which we're not going to get it exactly like it would be constructed. We'll try to get it a little bit closer. There is a tool called the coping tool. So if I click on my truss and I go up here to where it says apply coping, I can pick this one and then the top cord, and you can see it's kind of shaping itself to having a relationship with that diagonal member. So, and I can just keep going around and repeating that for all of them. You know, this one is touching, which is, you can leave it as it is or make them consistent around. And I just go around the whole truss, making that revision. When we get over here, we're going to click on the bottom one and then the top one. And again, this is not exactly how it would be built, but to sort of suggest how the relationship might be. And of course, those metal plates are what are used to attach them and secure them. Okay, so there is our truss. Let's take a look at it in 3D. All right, we want it to bear on the wall here, and we want it to have that overhang. Looks good. I'm going to go back to level 3, and I'm going to click on my new truss. Make sure it's selected here. Can you catch it? Move in a little closer. I'm not sure I got it. See here. Okay, maybe I did. All right, I'm going to make an array, 16 of them. 16 inches on center. Okay, let's take a look in 3D, make sure everything looks okay. There it is. Go back to level 3 and repeat the process. Array, 16 of them. Oops, no, let's redo that. We don't want to repeat it. We want to do, click on it. Array, yes, 16 is correct. And this time you want to lead it to the left. And again, we'll look at it in 3D. And there we have our wood roof trusses.